So Algebra 1, we're in 2.4. I didn't write every speck of notes on the board that is on your paper, because some of it I can just read from the paper. It's sort of a waste of time for me to write it on the board when it's already written on your paper. So if you don't have your 2.4 notes paper handy, maybe take a pause and go grab that paper and come back, because I'm working from this. There'll be some things I'll read to you, some things I'll ask you to try at home when we get to them, so that's an important paper to have with you. So there's a few words of the day. So the first word of the day is a thing called a term. So in algebra this year, you'll hear me referring to terms fairly often. A term can either be a number, or it can be a variable, or it can be a product, meaning multiplying those items. So 3 would be an example of a term, because it's a number. X would be an example of a term, because it's a variable. 3x would be an example of a term, because it's multiplying a number and a variable. Terms look like that. Numbers, or variables, or both if they're multiplying. Coefficient is a word you'll hear me refer to through today and through the rest of the year and the rest of your math life. The coefficients are just the numbers that are in front of the variables. So this has a coefficient of 3 for that term of 3. This has a coefficient of 3 for the term 3x. This has an invisible coefficient of a 1. Anytime you don't see a coefficient in front of a variable, invisibly there's a 1. So the coefficient for this term would be a 1. Like terms will be one of the main themes of today. Like terms I could explain in one of two ways. Like terms are only different with their coefficients, or I could say like terms have the exact same variables. So if I wanted to do a like term for 3x, I could do 4x, because they have the exact same variables. The coefficients are different, although the coefficients even could be the same. But the variables have to be the exact same thing. The coefficients are different. So if I went like this, those are now unlike, because this x is squared, this x is not. Those variables are a little bit different. If I threw 1x and another 1x, those are like terms, because they both have the same variables. If the coefficients are the same too, who cares? If I threw in something like 1y is unlike with these because it doesn't have the same variable that the other ones did. If I did something with 3 like 7, 3 and 7 are like terms. They have the same variable in the sense that neither of them even has a variable at all. So those are like terms. Like terms have the exact same variables, or if you want to look at it oppositely, if the coefficients are different, who cares? But the variables have to be the exact same thing. If I asked you to list me the terms of this, this is called an expression. It's made up of several terms. Someday we'll learn the word trinomial. This is actually called a trinomial because it has 3 terms, and tri usually is a 3 prefix. But there's 3 terms here. One of the terms is 7x squared. The next term is negative 14x. The last term is a 9. Any sign goes with the number that follows it in terms of being part of the term. So this term, this 9 term is positive. The 14 term is negative. The 7 term is positive. But there's 3 terms here. The coefficient of this term is a 7. The coefficient of this term is a negative 14. The coefficient of that term is a 9. So that's the idea of terms, coefficients, that's what these things mean. What I would ask you to do now is to take these 1, 2, 3, 4, 5, 6, 7 questions. On the paper it says like or unlike. I did 7 pairs of terms down the list. Pause the video and write down whether you think those are like or unlike. And then when you do that, unpause, and I'll still be here talking about whether they're like or unlike. But as always, you're going to get more out of this if you pause the video and engage your brain and think and do and practice and test yourself than if you just listen to me just say stuff. Okay, so give a pause. And then when you're back, okay, the first one is unlike because those variables are different. X versus Y, those are different. First one, unlike. Second one, also unlike. We have an X on the one and nothing on the other. That's different. Anytime the variables are different, that's unlike. The third one is also unlike, because I positioned the exponent in a different spot. The first term has 2 of the y's. The second term has 2 of the x's. That's different. So we're unlike, 1, 2, 3 in a row. Fourth one is finally like. When there's no variables at all, that's considered like. For the fifth one, since they both have x's, that's like. For the almost last one, they both have x's, that's like. It doesn't matter that one's negative and one's positive, those are still like terms, because like terms just focus on the variables being the same. And the last one is also like. Even though I put them out of order, going back to yesterday in the commutative property, you can switch the order anytime you want to. So they each have an A, they each have a B, those are like terms. As a quick aside, I'll throw out there, make sure you're absorbing the information a little bit at a time that have been in the other videos. If you right now have no idea what the order of operations is, you need to go back to either the 2.1 or 2.3 videos and get the refresher of what the order of operations was about. If you have no idea, if I'd say to you right now, if you take a negative number in parentheses to an even power, if you have no idea that that's positive, or any of those other exponent rules, you need to go back and watch the 2.2 video or the 2.3 video and get a refresh on that. You want to get those things practiced and worked out. If you're not doing that, you're not really doing your job as well as you should be doing it. From yesterday, if I'd say to you, what's the transitive property? And you're right now thinking, I have no idea what the transitive property is. Or if I said, write a algebra sentence for the distributive property, and you think, there's no way I could write an algebra sentence for the distributive property. Or if I'd say to you, if A equals B, then B equals A, what's that called? If you have no idea what that is called, you need to study that, okay? You're not doing your job at home as well as you should be if you have no idea what any of those properties are. If that's a total blind spot for you right now, you need to go back yesterday, check out the 2.3 thing, and rehearse those, practice that a little bit one way or another. Today there's no vocab quiz stuff building off of this, but they are words you need to know even though it's not a quiz. Like just to get through Algebra 1, you need to know what a term is. You need to know that the coefficient is the number in front. You need to know what like terms are. The main name of the game today is combining like terms. Combining like terms is one of those types of things like distributing. I mentioned yesterday's video, distributing you'll do hundreds of times this year. Combining like terms you will do hundreds of times this year, maybe 1,000. More likely to do 1,000 combined like terms than 1,000 distributes, but you're going to do it over and over and over and over and over again. So the paper explains to you, the rule on combining like terms is just to add the coefficients. So I'll do one, and then I'll ask you to pause and hit up the rest of these. These are like terms. If I ask you to combine these, just check the coefficients. 7 is positive because there's no sign before it. 4 is positive because there's no sign before it. If we combine positives and positives with the add rules, our adding rules tell us 2 positives make a positive, and we add. This would make 11x. The x part, the variable part, we do not change. So x's and x's still stay x's, don't mess with that. Just look at the coefficients and add the coefficients. Positive 7, positive 4 is positive 11. As a what if that were a negative 7, we'd have a little different adding rule. If negative 7 is adding with positive 4, when we add different types, that depends on the bigger one, and we'd subtract. So that one would be negative 3x. If I wanted to change that instead, now it's 4 that's negative and 7 that's negative. Each number keeps the sign that's before it to the left of it. So negative 4, negative 7 added, that would be negative 11. Because the rule on adding 2 negatives is keep it negative and add them. If I did this, now it's a 4 that's negative and a 7 that's positive. And we're going to think about adding. Now, again, depends on the bigger one, which is positive. We'd subtract. We'd get a 3. But I'll change it back to the way we came in. We came in on a plus, so that would be an 11. If you think you get the point, fire through these give me a pause, and then I'll be talking again when you come back to me. For this, we don't change the y squareds. Leave the variable stuff alone. Just look to do add rules. 4 is positive, 9 is positive. When you add two positives, it makes a positive. We just add them together. If one of these had been negative, it would have depended who was bigger. We would have subtracted on that rule. This, hopefully you remembered from a minute ago, when you don't see a coefficient, invisibly there's a 1. That's an important thing to just have in there, have in your brain, keep it. So when we add these, don't change the x's. X's in the problem, make x's in the answer. Positive 1, positive 6, add them up. That is going to be a 7x. This we have to do in groups. There's an x group and there's a y group. We need to keep the unlike groups different. So in the x world, there's a 6 that's positive. There's an 8 that's negative. When they're different signs, it depends on the bigger, which is the negative version, and we subtract them. So x's world is -2. In y's world, positive 7 with -9, the negative is bigger. We're going to go a -2 with the y. If that had been a positive 2, I would need to put a plus here just to have a connector. Okay? Sometimes positive signs, you don't write them. But if you don't write a positive sign there, it looks like that's all multiplying, and it isn't. So positive terms, we want to get pluses. Like we had on the very far left, I had a plus here to just separate term from term. For this, again, I'll need to make an x zone and a y zone. My x zone is created by these, and actually I'm going to grab an eraser, because in the x zone, a positive 6 with a -6 would make 0 of those x's. I'm better off to not even write that. Just leave the x's completely out of it. Those x's would eliminate each other. Zap. In the y's, 3 is negative and 4 is negative. When they're both negative, we keep the negative for our add rules, and we add them up, we get a 7. For this, I need an A group, a B group, and a number group. There's nothing like with the +7. +7 is one of a kind. So I'm just going to leave +7 alone. Just don't touch it. Just copy it over there. The 9b. There's nothing like with 9b. So just copy the +9b. Don't change anything with that. The A's are what we need to combine. 2 that's negative, an 8 that's positive. Adding when they're different depends on the bigger one who's positive, and we subtract to get 6. If you temporarily blanked on this one, we need to start off by distributing. So if that's enough of a tip to get you going again, pause me, distribute that, and come back. But this problem starts with distributing. Distributing means that 6 multiplies everything in there. That's going to make a 12 and an 18. 6 times 2 is 12, 6 times 3 is 18. 4 likewise has to distribute. When 4 distributes, 4 times 4 is 16, 4 times 7 is 28. Then we'll look for like terms. So in x's world, there's a 12 positive and a 16 positive, that's 28. In the y world, there's an 18 and a 28, so that's 46y. And since it's positive, we need to throw a plus in there. Let me throw a quick change at you on this one. Let's go change, 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 change. This will no longer be the answer. Take the changed one, pause me, retry, see how that goes. So when you come back, how the change would happen, that would be a minus because we copied. This would still be a plus because negative times negative makes positive. This wants to change this sign, that would actually stay the same. And this would also want to change this. And since I made all those changes, it's actually the same as where we were before. So when we do this combined, it's half of that answer. It's still a 28x, but it would be a plus 10y because positive 28 offsets a lot of the negative 18. So the next thing then I'll ask you to do, we're almost to the bottom of the page. There's a little note here to do 1, 13, 21, 37, 45, 53. So before you hang up on the video, try those 6. Pause me, try those 6, and when we come back, I'll show you, tell you, talk to you about how to do those 6. And then the homework's going to be on 64 from 2 to 54 even. But I would highly suggest self-check 6 of those, 1 from each little group, before you try to do all these even ones by yourself. So pause me up, hit those up. So for number 1, they just want to know for the first group of 12 whether things are like or unlike. Number 1 should be like. Okay? Both terms have an x, both have 2 of the y's, both have a z. The variables are exactly the same. Those are like. That's all you have to do on 1 to 12 is say that they're like or unlike. And you could put an L for like and a U for unlike if you want to save your pencil a little bit. I'd be totally fine with that. 13 down, the directions just say simplify. In math, that might be the first time you've seen a thing where the directions say simplify. Simplify essentially means do everything you know how to do to make this get as small as possible eventually. So for 13, what we are trying to do is combine like terms. 13's answer would be 8x. You don't change the x's, the x just makes them like. You just copy the x into the answer, and then the add rules with a positive 3 and a positive 5 would make a positive 8x for 13. The next one we were trying is 21. 21, we have 2 pairs. So the first 2, 5x and 2x, are like terms. The 5 and the 2x should make a 7x, plus the back 2 should make a 7x squared. Remember that that 4th term has that invisible 1. So the 1 wants to add the 6 to get 7x squared. The order you put these in doesn't matter. So when I just said the answer on 21, I said 7x plus 7x squared. If you had 7x squared plus 7x, that's okay too. It doesn't matter the order, you just need to have the signs still and the numbers still with the right stuff. So a question like this, you could say positive 2y first and save the minus 2x for last. But the x has to stay married to the negative 2. The y has to stay with the positive 2. This answer could be 10y first plus 28y second if you had that. Then we're down to 37. 37, we go with copy the 4 plus, and then do a distribute. The 3 has to multiply the 2. The 3 has to multiply the 1 on number 37. And then if you combine these, those would make a 7, positive 7, because everything's positive there. So either 6x plus 7 or 7 plus 6x, whatever you like on that. 45 has a double distribute. So the 4 goes with m, plus the 4 goes with n, plus the 3 goes with m, plus the 3 goes with n, and then combine. This and this would make a 7m. The other ones would make a 7n. So 45, 7m plus 7n. 53, we get a fraction involved. So the first group there, if you're doing half of those numbers, just divide the numbers by 2. So half is going to hit the 4 to make that be a 2a. Half is going to hit the 2 to make that be a 1b. For the 1/3 stuff, just divide by 3. Okay, so when 1/3 hits 6, 6 divided by 3 is 2. Minus 1/3 of the 3 is a minus 1b. The negative 1b and the positive 1b are going to wipe each other out, and you don't even have to write that. There's 0 left of that. The a stuff would make a 4a on 53. So if you got those right on that selection of odds, you should be fine on the evens. Just plow forward and do them. 64, 2 to 54 even. The only thing I would caution you of is make sure you're absorbing some of that vocabulary again. The properties, the exponent rules, the order of operations. Make sure you're working that out a little bit. I mean, not every day of your life, but you don't want to go 2 weeks and then come back to school and I'm like, hey, here's a quiz, what's the order of operations? You're like, I have no idea what the order of operations is. When did we ever learn that? 2.1, check that out. Make sure you're trying to keep current on that stuff. That's it. See ya.